start the class. So as far as your Python syllabus is being concerned, so we have been completed approximately 2.5 units. So let me navigate towards that particular Python programming syllabus. So look at this, we have completed approximately this control structures, dictionaries, and everything has been completed so far. And we would like to finish today a design with the functions. Let us take this particular kind of thing here today. So I'd like to finish off the class for today is a function as abstraction mechanism and design with recursive functions. These two will be gets completed today. And tomorrow we'd like to go ahead with the problem solving with the top-down design. So it is one of the kinds of problems which is very important in our computer science as far as the structured programming languages are concerned. So these are very, very important. So however, we would like to finish up this topics, these two. So more about functions and design with recursive functions. These two must be gets completed today, and we'll move forward towards the completion of the syllabus by today onwards. So we'll have a class continuously by today onwards. Okay, let us have a look. So most of the cases today it is only theoretical part only. So functions are a Python, whatever the algorithm you can consider here. So that particular algorithm is supposed to be constructed or implemented by using Python's control statements or Python's built-in functions. Actually, there is no point to be develop your own functions as far as Python programming language is concerned, because in Python programming language they do have very huge in number of methods, very huge in number of packages are available. So that is why people are using Python very extensively in their implementations of any kind of problems here. So actually, using built-in operators and built-in functions of Python, so you can develop or you can solve any kind of a real-time problem. There is no need to implement your own functions, but as a particular programming language, if you consider any programming language, that particular programming language must have some rules and regulations to be implement some number of tokens for that particular programming language, such as data types. Some number of data types are required here. Data types are required here, and control structures are required here. So control structures and functions, and then structured kind of data types are required while designing any kind of programming language because of only that rule. So here functions have been, user-defined functions have been given to the users to implement. Okay. Then, if any program, whatever the implementation kind of program, if you consider that particular program will be very complex and very huge in terms of doing some kind of exercise, then so functions are required. Basic importance of these functions will be, if you write a particular program without using any functions, if you write a particular program, it is very difficult to verify, and it is very difficult to maintain. So that is why functions are required. So you have to divide or decompose the entire problem into simple pieces, and each piece will be considered as a simple function. Therefore, if any problem will be raised, you directly go to that particular function and examine what kind of bugging will be there, debugging or bugging will be there. Due to some internet connection, the session will be continuously not in a perfect mode. So please try to understand. So by tomorrow onwards, we'll have a class at my home. Today I'm in the college, so that is why again college internet connection is not that much good. So however, whatever it may be. So importance of functions will be if a big problem is being solved by you, then to maintain that particular complete code as a single entity will be very difficult. Okay, very difficult, extremely complex, and very difficult to. Each entire program will be divided into several number of pieces, huge number of pieces, and each piece will be considered as one particular function. If any problem will be raises at any point, you directly go to that particular function and examine that whether that particular function will be executed properly or not. So it is very simple. Each piece will be separated for separate function, and it does have its own significant work or coherent work. So that is why, so you could identify where exactly the problem will be, and it is very easy to maintain. Okay, so that is why functions are required. That is the basic point where exactly functions are required. And the functions also we implement to specify the abstraction. To specify this abstraction. Probably, so in our C++ class, you got one particular object-oriented programming kind of feature. That feature is abstract. Abstract in the sense, so hide the details of entire activity, and you have to specify only single word answer. Such kind of thing is called as abstraction here. And to maintain this particular abstraction, yes, functions are required. Okay, and so this abstraction could be hide the details of one particular problem. So it could be I hide the details of one specific problem, and allows the programmer to do so many things with a single name. So functions will be always called with a single name only. So based on that particular single name, you could execute many issues are there or many problems are there. So such kind of operation is called as so abstraction. And moreover, functions are always eliminate the redundancy. How could you say this is redundancy in the sense, for example, binomial coefficient n factorial divided by so r factorial into n minus r factorial. For example, if you consider this particular problem, factorial could be developed by you for thrice. So n factorial for once, r factorial second, and n minus r factorial third. If you don't have any facility to use the functions, then the same type of code will be used for 3 times. So therefore, redundancy will be gets increased. Okay, redundancy in the sense same set of instructions will be repeated for several number of times, which could be always waste some storage space also. So for doing such kind of operations, so functions can be used for not redundant uses of this specific set of statements out there. Okay. So best example is this one only. This is the best example where exactly you have to specify the redundancy. Redundancy in the sense duplication. The meaning of actual dictionary meaning of redundancy in the sense duplication. It could be eliminates the duplication of set of statements within the development of any particular program out there. Okay. Once you have to define your function, if any function will be defined by you, so it could be called for a number of times, any number of times. If you are supposed to make your function as a library function, of course, your function could be used by many people and many times. Code will be, I mean, for example, a particular function will be defined with some 20 lines of code. These 20 lines of code can be executed for a number of times by calling single statement. Okay, so that is why a redundancy could be gets eliminated while functions are supposed to be used. And it is also very easy to debug your program. Already I have given this statement here in the previous just before a couple of minutes ago. So debug the program is very simple when compared to So very huge program which is going to be taken into consideration out there. Okay, so that is also one of the very important kind of operations or features of the functions here. And if any problem will be raises in your program, no need to open all the program. You just call or you just go through that particular area where exactly the problem will be raises. If that particular area will be a function. Okay, if you write a particular program without functions, then you have to go through, so right away from first statements to last statement. Therefore debugging time will be very huge, where you have to divide the program into several pieces and each piece will be a function. Then obviously your debugging is very easy and the maintenance also very easy. So these are the different kinds of uses or features of your functions. Okay, and functions will be always hide the complexity also. Very huge complexity will be get cited. Of course, you may know something about complexity in your next course, that is design and analysis of algorithms. Thereby, you could know the functions here. So let me go ahead and take the information regarding to the recursion. Already you have learned this particular recursion in our C programming language. So let me repeat the same here. Recursive functions are frequently used by the designers, so to design the algorithms when the specific function will be in recursive mode. Recursive mode in the sense, same kind of operation could be done, so for number of times while running any particular function, the same kind of operation will be done for number of times will be called as the recursion. Okay, so normally recursive functions are not supposed to be used because these will be increase the complexity of your program. These will be increase the complexity of your program. So that is why recursive algorithms are not supposed to be used. But some cases are there. For example, quicksort algorithm. For example, towers of Hanoi problem. For example, Fibonacci series. If you consider these are recursively identified. If you take the example for recursive algorithm, so let me consider Fibonacci series in the sense, the first value for Fibonacci will be 0, second value for Fibonacci is 1. These two are the default values for the Fibonacci series. If you have to generate next value, recursively you have to take this particular value, and recursively you have to take this particular value and apply addition between these two. Then you could get 0, 1, and again 1. And the next value could be generated here in the sense, so n minus 1 and n minus 2 locations value could be taken into consideration. They will be added together. You could get 2 here. So this operation will be recursively done. Okay, so how 2 will be get? So just before location this value, then just before location this value, these two will be taken into consideration and apply addition between these two, you could get this one. And if you want to get next value, so then you would like to consider as 3. How could you get this one in the sense? So just before previous location value and then previous location value. That is, so -1 and -2 location values will be taken into consideration. Apply addition between these two, you could get third one, and so on and so forth. So this particular kind of operation will be called as a recursive operation. For such kind of problems, you must use recursion. You must use recursion here. Otherwise, recursion could not be so implemented here. Recursion will be taken huge amount of time. Let me explain how it could be taken huge amount of time. Then what is the definition of the recursion? So recursion definition will be very simple. Already you have learned in your previous programming languages. Then though I'd like to give you, a function can be called by itself for finite times. Recursion must be gives you, so for finite number of times. It must not be infinite. It must be finite number of times. Is called as recursion. A function can be called by itself for finite number of times. Then it is called as recursion here. And the syntax will be seen in such a way. You can see, you could define your function something like this in Python, like this definition. And one more thing, very important thing to be remember for recursion is recursion must be taken at least one parameter. Without parameters, recursion cannot be possible. You please remember this one. Without parameters, recursion cannot be possible. I repeat, without parameters, recursion cannot be possible here. So that is why recursion is very, very important, and recursion must be taken at least one parameter. At least one parameter. At least one parameter must be taken by the recursion, and recursion must be maintained. So a condition here, if structure will be taken into consideration, if structure must be taken single condition, and this condition is known as base condition. This is called as base condition. You must be maintain a base condition. If this particular base condition will be DIY. Okay, base condition. If base condition will be written true, your recursion is gets over, or your recursive calling is gets stopped. If base condition will be a repeat, if base condition will be written true, obviously your recursion is gets completed. If base condition is false, then so you could go ahead and call the recursive calling of your function here. Okay. If base condition is true, let me take another color, then you could identify. If this base condition is so getting true, so thereby what you could say here, recursion is gets over. Okay, recursion is gets over. Whereas if this base condition will be written false, yes, recursion is being continued. Recursion is being, if it is false, so recursion is being continued. Okay, so that is what you need to remember. Okay, base condition is very, 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 very important for any kind of a recursive procedure or recursive function. Without the base conditions or without the base conditions, you could not implement any recursive procedures. Point number one. That is the first point you need to take into consideration. Base condition must be implemented, and if this base condition will be written true, your recursive call will be gets over. If base condition is false, your recursion will be continued. Second condition to be remember here is you never ever use iterative structures. Iterative structures in the sense while for, these two are not supposed to be used. These two are not supposed to be used. So while it is a while, the while loop or for loop, these two loops are prohibited to use in recursion. You must remember these two. Okay, a base condition must be specified. If base condition will be true, recursion is gets over. If base condition will be gets false, then recursion will be continued. Second point you need to remember, iterative structures or iterative control structures, they must not be entertained in recursion. Okay, let us do one or two programs for recursion, then you could understand very easily. So it could be very easy to understand. Let me give you the statements here. First statement will be, as you know very well, so factorial of given number. Okay, this is the first statement where exactly you need to consider factorial of the given number. And second problem will be, second one is addition of two integers. Third problem is generation of Fibonacci series, and fourth one is producing nth Fibonacci number, not series actually, number. Likewise, you do have many. Likewise, you do have a huge number of kind of things are there. Already, I believe that you people have learned about this one here. So, however, I'd like to give you first two programs. First two programs I'll give you, if possible. So, third one also. So let me go ahead and take the operations here. File new. Yeah, the new program has been get open. Now define factorial of. I'd like to take an parameter that is n. Okay. So base condition will be if n is so less than or equal to, actually less than or equal to is not supposed to be taken, equal to 0, then obviously you could consider a return. Wait for a bit. Yeah, return 1. Otherwise you have to return so n into facto yeah FACTO factorial of n minus 1. Okay, so this is the specific function here, and it could be, let me calculate this one, how this could be gets work. I'd like to give you the execution pattern also. Let me explain you. Let me take um, define. So let me define the main program here. Define. Already we have taken main program cannot be taken even single parameter also. It could be take. What is the importance of main function here? Main function is always used to take some input from the user and can be called the functions. That is the importance of main here. So therefore, x will be equal to integer of input of enter any integer. So this integer must not be in negative value. So it must not be a negative value. We need to check out in the main program itself if so. If x is less than 0, what exactly you need to specify? Return. Nothing has to be written here. Else you may be called some y will be equal to FACTORA factorial of x. Sorry, and then print after execution of this factorial of x is equal to y. Okay. That ends your problem. So I'd like to explain this one. Let me copy this one for a while. Okay, let me execute this one for a while. Before execution, let me save this one somewhere else in my where it is Python. Yeah, you see it is Python programs factorial.py. Yeah, let me execute this one. What is this? Sorry, here comma has been missed. That is the problem. Yeah. Um, why it is not taking here? Okay. Stuff written print enter an integer. So let me consider this is 5. So factorial of 5 is 120. Yes, it is okay. There's no problem. Then here, let me explain in terms of how this could be gets executed in terms of so recursion in any programming language. Let me explain this one for a while. So what actually done when recursion will be taken? So normally, let me take it as f of some 5 will be taken by me. Actually, our function name is factorial. So f of 5 will be taken here. What are the conditions we have implemented here? The conditions will be if n equal to 0, return 1. Otherwise, n into factorial of n minus. So here, how this could be? So n in the sense the parameter. The parameter is 5. So here, does 5 will be equal to 0? It could be checked that whether it is equal to 0 or not. Yes, it is not true. So it is false. So that is why it could be called 5 into so 5 into factorial of 5 minus 1, that is 4. Again, it is going to check that there is no answer at this moment. You could not find any kind of answer at this moment here. So there is no answer at this moment. So factorial of 4 here. So here, then what exactly it could be checked here? Immediately, one more factorial has been called. So therefore, 4 will be equal to 0 or not. Yes, it is again false. It's not true. It is false. So that is why. So 4 into factorial of 4 minus 1, that is 3. 3 has been called. Then here also one more time it is going to check that whether 3 will be equal to 0 or not. Again it is false. It is not true. So therefore 3 into factorial of 3 minus 1, that is 2. Okay. It also checks that whether 2 will be equal to 0 or not. It is not true. So that is why else part will be taken. So 2 into factorial of 2 minus 1, that is 1. So 1 is equal to 0 or not. Let's also check one more time. Yes, it is again false. Because of false, so 1 into factorial of 1 minus 1, that is 0. Now the things will be changed. Let us have a look here. So does this particular 0 is equal to 0 or not? Yes, it is true. When it could be gets true, then obviously your recursive calling will be gets over here. That's what I told you. So here when n will be equal to 0, then what we are returning, that is 1. So since 1 is returning, the value which is being produced by this statement will be 1. 1 will be submitted over here. 1 will be submitted here. So here the value will be 1 into, factorial of 0 value is 1, that equal to 1. Okay, the value is 1. This value will be submitted at this function header. Okay, here factorial of 1 value equal to 1, and the actual value is 2 into 1 will be equal to 2 here, and this 2 will be submitted at this place here. So 3 into factorial of 2 value equal to 2, so that equal to 6, and 6 will be submitted here again. So 4 into factorial of 3 value equal to 6, so therefore 4 into 6, that is 24, and this 24 will be submitted here, and 5 into factorial of 4 will be equal to 24. 5 into 24 equal to 120. Yes, this 120 will be submitted to the user. Okay, that is what. So look at this. How many times it is going to calculate its value? Let us examine. So this is the function call. This is the calling of the function here. This is the function call. After calling, first calculation, and then second calculation, and then third calculation, and then calling instead of calculation, let me call it as calling, function calling, fourth calling, and then fifth calling, After fifth calling, yes, you got a value as true here. This is true value. After truing, after the function, I mean the if structure will be gets true, then function calculation will be takes place here. This is the first calculation, second calculation, third calculation, fourth calculation, and fifth calculation. How many times you could observe here? During this one, so how many number of comparisons will be took place? First comparison, second comparison, third comparison, fourth comparison, fifth comparison, and finally sixth comparison. At sixth comparison, you got the true. So how many calls are there? Five calls are there here. Five different types of function calls will be happen. How many calculations are there? Five calculations are there. How many comparisons are there? Six comparisons. Totally, how many? What is the value of this one? So totally, this is 16. Okay. So you have called or you have to send a parameter 5. So this 5 will be leads to calculate the factorial of 5. It will be taken 16 different types of operations. Okay, approximately 5 cube. Sorry, 3 into 5. 3 into 5 plus 1 actually. 3 into n plus 1. So these many times the calculations will be gets happen. So that is why factorial cannot be, not exactly factorial, recursion cannot be used for implementing any kind of algorithm in actual implementations because it could be taken huge amount of time. Okay, so that is why it could not be used here. So that is the basic point where exactly you need to remember why this recursion cannot be used here in the sense. This is the reason here. Okay, and let us take one more example. Second example will be addition of two numbers, addition of two integers. Okay, let us take this particular example also. Okay, let me save this one and let me delete the file, save as. So recursive addition, recursive addition. Definition, addition of two numbers. First one is n and second one is n. Okay, two numbers. So for example, if n equal to 0, the final answer is m. If n is equal to 0, that is m plus 0 equal to m only. So that is the meaning here. If n equal to 0, then return m. Whatever the value which is having with m, that could be returned. Else, what exactly we are trying to perform? What exactly we are trying to perform? You need to call return addTwo, that is my function name. So of here you need to pass two parameters. So I'd like to reduce the value of n by 1, comma, I'd like to increase the value of m by 1. So n will be reduced, m will be increased. Obviously, so when n will be reached to 0, obviously m will be having n plus 1. Okay. So this is some a will be equal to integer. So input, enter first value. Okay. So here we need to take one more specification here. Sorry, one more closed brace is required here. B will be equal to, so integer and second value. Second value. Okay, second value has taken. Now some C will be equal to addTwo of A comma B. After adding, print addition of two integer C's, comma C. A simple program, a very simple program. That's very simple program. Let me run out this particular program for a while. I'd like to take some value that is 10. I'd like to take second value that is 24. So it will be equal to 34. Okay. So simple program, very simple program, which is used to develop by using a recursive mechanism. Okay. So in this way, you can develop your particular program using recursion here. Recursion is very simple task. We need to understand a base condition must be implemented here. If this particular base condition will be gets true, obviously we would like to conclude our recursion. If this base condition will be gets false, then else part will be taken. Obviously, in else part, we have to call our recursive call of our function. So therefore, recursion will be gets continued up to this function will be returns false. When this function will be returns true, obviously your recursive call will be gets over. So that is the point where exactly we need to consider. And let us take a third one also, because Fibonacci series will be taken into consideration. Let us take a third one also. So recursive Fibonacci dot py. So the EF would like to take one parameter FEBONACII Fibonacci of, let me take n. So here two conditions are available as far as Fibonacci is concerned, because the basic values of a Fibonacci series will be starts with 0 and starts with 1. Add these two numbers will be called as next number, and so on. So the two base conditions will be there. If n will be equal to 0, then what you are supposed to return? Return 0. Else if so n will be equal to 1, what you are supposed to return? Return 1. So else, if these two conditions will be returns false, then what exactly we are trying to perform? We are trying to perform return. So FEBONACII Fibonacci of, so n minus 1. So previous term n minus 1 previous term plus, where is this plus? Fibonacci of n minus 2. These two must be added together. Okay, obviously you could get next value. So this is the function. Then like to consider, so some x will be, or a will be equal to integer of input of enter how many values in the series. How many values in the Fibonacci series? Okay. So here we need to take one more extra loop here, because we need to send. So we need to call this Fibonacci for several times, so that I will be equal to 1, while so I less than or equal to a. So some p will be equal to FEBONACII Fibonacci of I, first value. Okay, let us start with 0 here, because first value is 0. So that is why let us start with 0 and less than a. So simply speaking, less than a. Fibonacci of, so I. And then after getting this particular Fibonacci value, print, the value can be printed here, b, comma, some space, at least. Okay, whatever. E and will be equal to some space, at least one space between these two values. Okay. So this is what, okay, sorry, one more thing will be there. I will be equal to, otherwise I plus equal to 1. I will be gets increment. Otherwise it would be goes to infinite. That could be a biggest problem for us. Okay. This is the way of generating Fibonacci series. Fibonacci series. Okay, let me run this particular program for a while. Let me run this particular program for a while. to save this one. Yeah, let me run this particular. How many values in the series? 10. 0, 1, 2, 4. Why it is 4? 8. So here there's some problem will be raises here. 8, 16, 32, 64, 128, and 256. It is not correct. It is not correct. Somewhere else we did. Yeah. The problem is n minus 2. We did n minus 1 only. We did n minus 1 only. We have like to take n minus 2. N minus 1 plus n minus 2 actually. Okay. Now let me run this particular program one more time. So now you could get 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. Okay, these are the specific values which are available within the Fibonacci series. First one is wrong and second one is correct. In this way, you can generate Fibonacci series values by taking the example of this. I'll send you these three programs to you through Google Classroom, and let me give you one or more assignments for you for doing such kind of recursive operations. Okay, that's what the class for today. We'll meet by tomorrow with continuation. Let me take the attendance for a while. Please wait. Yeah, thank you.